In this video, we're going to look at hypothesis testing, and we're going to look at one of the approaches that we can have. In our text, we're going to look at actually two different approaches, the p-value approach and the classical method. So we'll look at the classical method in another video. Okay, so let's first start with some definitions. First up, we need to know what a p-value is. So a p-value measures the probability that the data can occur by chance. Small p-values say that the observed values are unlikely to occur by chance, and large p-values say the observed values are likely to occur by chance. So really, we don't want any of our data to occur by chance, so we're looking for small p-values. Any p-value that is less than the significance level, which we call alpha, is called statistically significant. Okay, so let's look at the approach. I'm just going to go step by step, and then when we do specific examples in the next few videos, we'll actually put some data in there and find out what to do in our calculator. So right now I'm just going to demo what we would look for in our calculator, and we'll actually do the real-world examples. Okay, so first up, we always have to remember that we have to check that normal conditions are met. So for means, we check n is greater than or equal to 30 and no outliers. For proportions, we check that n times p times 1 minus p is greater than or equal to 10. And then a quick little check to make sure that our sample comes from a simple random sample. Okay, so once those conditions are met, we're ready to begin our hypothesis test. Step 1, we have to determine the null and alternative hypotheses. So that's exactly like what we were doing before. We write our null is either mu equals whatever number or p equals whatever proportion, and then we decide about the alternative hypothesis, which is that greater than, less than, not equal to. Step 2, we're going to select a level of significance alpha. Most of the time the examples will give you a significance level, but I just want to put a little note in here. If none is given, use an appropriate level for the situation. So I know the book says always use alpha equals 0.05, but that's not always appropriate. If we're talking about something that's really extreme and is going to affect a lot of lives, say like a health, medication, whatever, we need to maybe select that alpha a little bit smaller, like 0.01. So just make an appropriate level for the situation. Step 3, we're going to find the test statistic. This will be your z-score or t-value. So remember, for means, if our sigma, which is our population standard deviation, if that's known, then we'll use that z-test, and we'll use that z-score for our test statistic. If we don't know sigma, but we do know s, which is our sample standard deviation, we're going to use our t-value, and then again a t-test. And then for proportions, we never have to make that choice. It's always a z-score, and we've got our formula here. So we'll review those formulas when we do specific examples. Okay, so once we've got all that in place, we are ready to determine the p-value. The p-value is again going to measure the likelihood that your data occurred by chance, and that's actually the area under the curve that you get from the test statistic. So what we want to do is we want to draw a normal curve, because we said it was normal, label the test statistics. You can see I've got, for the not equal to, that's a two-tailed test, remember, so I've got my negative z and my positive z-score. For a right tail test, I'm just going to mark it once, and that will give that right area tail. And then our negative z for our less than, which gives us that left-hand area here. To actually find this area, you could look it up on the chart like we've been doing, or we can use our calculator. And I put a little note here that the t-values are labeled the same way. It's just a matter of what chart we're going to look up the area from, or what function to use in the calculator. So let me go ahead and go to the calculator and turn that on. Okay, so if we have a z-test and we're using a z-score, we're going to go to Stat, arrow over to Tests, and we can see that number 1 says a z-test. So if our population standard deviation is known and we're testing a mean, then we go to that z-test. If I click enter, we can see that we can either enter data, which we'll do in a list, so we'll do that in our examples, Or we can enter the stats, which is everything that we needed for our test statistic. We needed the mean, we needed our population standard deviation, we needed our x-bar, our sample mean, our n. We'll select the appropriate sign for our test, our two-tailed, left-tailed, or right-tailed, and then we'd press calculate. And that would calculate the p-value for us without looking on a chart. If I go back into stat, test, let me arrow down to t-test since we're talking about those types of tests right now. You can see that the menu is really similar. The only difference is this S right here, which stands for our sample standard deviation. And then back into that menu, stat, arrow over to test one more time. If we go all the way down to number 5, so we skip our 2 sample because we're not there yet. So I'm going to go all the way down to number 5, which says a 1 prop z test. So that's for testing proportions when we have a single proportion. And then when we get a little bit more advanced, we'll look at this 2 prop z test later. So if I enter that, a different type of menu pops up because we've got proportions. Remember, that's a different z-score formula. So we've got our p, which is our population proportion. So that's going to come from our null. That's why it has that little subscript of 0 here. It just doesn't show up as a subscript very well in the calculator. We've got our x and our n, which would be used to find our p-hat. And then again, we select our sign and then calculate to find that p-value. So we'll be using that later as we go through specific examples. Okay, so on to our step 5. So once we have our p-value, we're ready to make a decision. The way that we make a decision in the p-value method is we compare our p-value to alpha. If the p-value is less than alpha, we reject the null. Otherwise, we don't. And we always want to ask the same question. Is the p-value less than alpha? And then once we make a decision, we can just state the conclusion. Remember that conclusions are written, there is or is not sufficient evidence to support the claim, and we're always looking at the claim for the alternative. So we want to fill that in specifically to what the question is talking about.